Hello, Algebra 1. This is Mrs. O'Donnell, and today we're going to add and subtract polynomials. Our goals for today are to identify like terms and simplify polynomials using addition and subtraction. Our agenda for the week, I do have the Google form posted, so make sure you complete that after you've worked through some of those Delta Math sections. So what is a like term and when does it matter? So we've been talking about like terms a lot throughout the school year, but I think sometimes it's easy to still get confused. A like term is when you have an exact match or an exact label, specifically referring to your variables, right? So for example, if I had this variable here of 3ab, right, it's literally saying I have 3, maybe this is a hybrid, maybe you want to think about it like a label, an apple banana hybrid, right? So I have 3 of them. Okay, so I want to look and see, is there anywhere else that I have 3ab? Nope, I don't. I picked the one that doesn't have a match. Okay, you might be tempted to think, this a squared b is a match, but because of this exponent of 2, okay, it doesn't match exactly. All right, but if we're looking at that 2/3 a squared b, let's see if we can find any other a squared b's, right? So if I'm checking around, looking around, I see, oh, hey, I've got a 6ba squared. Well, it doesn't look like it matches exactly, but I know that I've got the commutative property of multiplication, which would allow me to rewrite this as 6a squared b, and now that variable does look like it matches exactly. So this actually is an exact match. That would be an example of like terms. Okay, let's see here. Let's find another example. I've got this 2yx, which I know, oh, I thought I clicked on green. 2yx, which I know is matching with my, there we go. There we go. 2yx, which I know is a like term with my 10xy. And I can look and see, are there any other like terms? No, there are not. All right, what else have we got here? Let's see here. 7xy squared. Well, I've got this negative 5x squared y. Doesn't match exactly. Can't use it. Oh, I've got this negative 3x, and that's a like term with this 7x right here. Okay, those variables match exactly, so they are in fact like terms and can be combined. Let's see, what else? Looks like I've got this p squared or negative p squared, and I've got a 4p squared. Those would be examples of like terms. They're both represented by p squareds. What else have I got? I've got this 5y and this negative y. Those would be examples of like terms. I'm trying to see, did I miss any? Negative 5x squared y does not match with my 7xy squared. I've got this negative y squared. That doesn't have a match. I've got a 2a. That one doesn't look like it has a match. And a 4p. That one also doesn't look like it has a match. So we've now matched up all of our like terms, right? So like terms really matter when we're doing addition and subtraction with monomials. All right, so when you're working with polynomials, right, we're thinking specifically about adding and subtracting today, right? So when adding or subtracting like terms, you operate solely on the coefficient and you treat that variable like a label, right? So if that helps you, right, think K for kiwi, A for apple, D for donuts. Make something up to help you remember that you are combining like terms, okay? Another thing that really helps me is when I have those constants, right? So for example, my constants in this situation would be my 14 and my 2, they're just my numbers. Sometimes it helps to think about those as money instead of giving them like a specific label. All right, we all are excellent at adding money, aren't we? Okay, so there's 2 ways that you can work with polynomials. You can work with them in sort of this horizontal fashion, or you can add and subtract them vertically, which might be flashing you back to, 2nd grade. You did a lot of vertical addition and subtraction, right? So if we take a look at what adding them horizontally looks like first, okay, we want to go through and we want to make sure that we have all addition in our polynomial, because if we have all addition, then we can use that commutative property of addition to sort of rearrange our polynomials so that we have our like terms grouped together and they're easier to add, right? So for example, I've got 7x plus 14 plus 2x squared. I'm going to change this minus sign to adding a negative 3x and then plus 2. And now I'm going to go through and I'm going to sort of rearrange so that my like terms are together. Okay, so let me see here. And you could even think about, well, anyway. Okay, so I've got 7x and negative 3x. So I can group those together. So I've got 7x plus negative 3x, right? And then let's see here. I've got this plus 14 and this plus 2. Those are like terms. So I'm going to add 14 and 2. And then sort of this last term that I have on here is that 2x squared. So now I've sort of grouped my polynomial with my like terms and I can combine them, right? So I've got 7x plus negative 3x gives me 4x's, right? And then I've got 14 plus 2, which is 16. And my 2x squared doesn't combine with anything. It just stays 2x squared. The last step when you're working with your polynomials is rewriting your polynomial in standard form, right? So it's always a good idea to finish by writing your polynomial in standard form. Okay, so you should have those descending exponents, right? So I have 2x squared would be my leading term, my highest power, plus 4x plus 16 would be that final answer. All right, so now that we've sort of added vertically, let's take a look at what, that wasn't too bad, but let's take a look at what it might look like if we do it horizontally. I mixed up those words. Now that we've added horizontally, let's take a look at what it would be if we added vertically, right? So in order to set this problem up, you want to try and line up your polynomials so you have like terms, just like you did way back in 2nd grade. You lined up that decimal point, right? Here you want to line up your terms in your polynomial, which is part of what writing them in standard form, it's why it makes it so important, right? So both of these polynomials are in standard form. They're already lined up for us. I could even fill in a 0x squared right here if I really wanted to. Okay, but it's not totally necessary. All right, so if I just start adding, right, I've got my 14 plus my 2. That gives me my 16. Right? And then I've got my 7x plus my negative 3x, right? So that's going to give me my 4x. And then my 2x squared is just right there. Okay, it doesn't add with anything. And I've got my final answer. Okay, so use whichever strategy you like best. Just know, oftentimes in algebra, you'll see it written horizontally because there's typically a lot of extra steps afterwards, but sometimes doing it vertically is a little easier to kind of line things up. All right, so next I want to take a look at subtracting polynomials. So when we're subtracting polynomials, we have to be really cautious of what this subtraction sign is doing to the entire polynomial that you're subtracting, right? And you almost want to think of it as you're taking the opposite, right? You're doing the opposite. Okay, so for example, and you could go through and work to change all of your signs, right? So I've got negative 4x squared plus 2, and then I'm minusing a negative 7x. So that gives me a positive 7x squared. And then I'm minusing a 10x. So that's giving me plus a negative 10x. And then I'm minusing that constant of 1. So I end up with that negative 1. Okay, so it's like you're distributing that negative through, right? You're basically distributing that negative through. Okay, so then at this point, you can go ahead through and you can look for those like terms to combine, right? So I've got this negative 4x squared and 7x squared. Those are my like terms. Then let's see here. I've got this 2 and this negative 1. So I'm going to add 2, add negative 1. And last but not least, I've got this negative 10x, okay? And let's see here. So I've got, if I combine my like terms, I've got negative 4x squared plus 7x squared, which gives me 3x squared. And then I've got my 2 plus negative 1, which leaves me with just a 1. And last but not least, my negative 10x hanging out on the end there. That doesn't combine with anybody. And of course, my very last step is putting the whole thing back into standard form, right? So I've got 3x squared plus negative 10x plus 1. And if you wrote that as 3x squared minus 10x plus 1, that's absolutely fine. It's the same thing. All right, so just like we did for our last problem, first we did it horizontally. Now we're going to take a look at what subtraction vertically would look like. All right, so we've got, let's write it out. So we still need to line our polynomials up, and we want to make sure that we have our polynomials in standard form. So negative 4x squared plus 0x plus 2, right? I have to fill in that placeholder. And then I'm subtracting my negative 7x squared plus 10x plus 1. Okay, so I'm subtracting this whole mamma jamma. All right, so you could distribute that subtraction sign through, right? Turn it to a positive, a negative, and then another negative, and then add. Or you could just subtract down and kind of think through it as you go, right? So negative 4x squared minus a negative 7. Well, minus a negative is a plus, so that's negative 4x squared plus 7x squared, which gives me 3x squared. 0x minus a 10x gives me negative 10x. And 2 minus 1 is just 1. And voila, we have the same answer. Our answers match. And now it's already arranged in standard form. How nice is that? Here we have a couple of math by example problems. You may want to take a minute, kind of work your way through these sample problems if you have some extra time. Okay, here's the back side. Take a minute, try some of these problems. They're really good questions to think through. You can go ahead and pause the video and just do them on a piece of paper. And last but not least, I have this challenge question for you from Open Middle. It says, use the digits 1 through 9 at most one time each to create a true statement. Okay, can you create more than one true statement with non-repeating digits? So you're trying to create your own polynomial here. Really fun challenge if you are stuck at home and looking for something to do. All right, last, I have today's Google form for you. Make sure after you've watched this video, you hop onto Delta Math, complete your sections for today, and then go into the form and complete your form to get that attendance credit. And that's all I've got for you. Thanks so much. Have a great day.